Welcome back to our next video for our Chapter 14 lecture series. We are going to continue with this example about athletes and the amount of pizza they consume. So, in a factorial ANOVA, we have at the very least 3 null hypotheses. In the simplest case, where we have 2 independent variables, which is what we're talking about, there will be 3 hypotheses. So without writing them symbolically, just writing them out with words, here's what they are. So we always have a hypothesis for a main effect, and this is what we talked about in our last video. In this case, it would be that there's no significant difference between the amount of pizza slices eaten by adults and teenagers in one sitting. We would also have a hypothesis about our second main effect, which in this case is athlete type. So there's no significant difference between the amount of pizza slices eaten by football, basketball, and soccer players in one sitting. Our last null hypothesis then, or hypothesis in general, would be about the interaction effect. So this then would be between our independent variables, which are age group and type of athlete. So our null hypothesis would be that there's no significant interaction between amount of pizza eaten and type of sports you play. Okay, so notice how my null hypothesis in each is that there's no change, right? So the means would be equal. Okay, so let's start then with the main effect for age group. So with age group, I have this. So adults eat 2 slices on average more than teenagers. So I want to find out, is this statistically significant? Okay, so that's what we want to find out using my sum of squares information. So now let's look at my second hypothesis for type of athlete. So I know that football players eat the most amount of pizza compared to basketball players and soccer players. So football players eat on average 5.5 slices more than basketball players. Basketball players eat 3 more slices than soccer players, and football players then eat 8.5 more slices than soccer players. That's like a whole pizza. This is kind of grossing me out. I can't think about it too much. That's a big difference when you just look at it. So our goal is to see if there is a significant difference. Okay, so let's first consider my interaction effect. So notice this right here, it appears that there's an interaction here because it doesn't follow the same trend as the other 2 groups, okay? So how do I test to see if it is significantly different or statistically significant? So when I run my factorial ANOVA test, it's going to produce an F ratio for each of my main effects and for my interaction. So I'm going to have a main effect for my age group, which would have an F ratio, a main effect of my type of athlete, which would have an F ratio, and I'd have a third value, which is an interaction effect, and that then would be age group by type of athlete, or how they influence each other, and that then would have its own F ratio. So each of these then would be compared with their individual F values from the back of the book. Okay, so you would go find the F critical values in the table, compare them together, and determine if the null hypothesis needs to be rejected or retained, i.e. failed to be rejected. Okay, so we always interpret the F ratio for the interactions first before looking at the F ratio for the main effects. We would always need to explore this first just so we can see what's going on. So if it is significant, it's really helpful to plot it, and we've talked about this a little bit before, but this helps you see where the effect is occurring. So like in our case with these different athletes, my plot would look like this, okay? So let's look at this. This graph and this graph aren't exactly parallel, but they're at least moving in the same direction, okay? Down here, however, I have adult to teenager that's increasing, and these 2 are both decreasing. So you can visually see that the soccer players aren't following the same trend as the other 2. So that then lets you know that soccer players then have something else going on. So this looks a lot like our previous image. So this is why I like to kind of draw these arrows increasing to decreasing with my different independent variables, just so you can kind of get an idea when plotting the actual values. So there are many possible combinations of effects that can make a significant F ratio for the interaction. So in our example, one of the 6 groups that we have might respond differently than the others. We could also have maybe 2 groups respond differently or 3 groups. It can be very complicated, okay? This is why we usually use computer software to run these numbers. So if the interaction is significant, it's the primary focus of our interpretation. Usually interaction is the main thing we look for. Sometimes, however, the main effects can also be significant and meaningful even if the presence of the interaction is significant. So the plot then can help you decide if it's meaningful. So for example, if all players increase in pizza consumption as they get older, but some increase much faster, both the interaction and the main effect for age might be important. So like slope would be something you'd want to pay attention to in your graphs, okay? So if one is increasing significantly versus others are just increasing very gradually, those are things to pay attention to. So if the interaction isn't significant, it can be ignored and the interpretation of the main effects is straightforward. So an example of that would look like this. If all 3 of these decrease at the same rate, then we can kind of ignore the interaction because it's not as significant. So that's all we're going to talk about in this video. I hope this helped you just kind of visualize where we're headed and what we actually will care about.